Prior to looking at the declaration, it's crucial to first comprehend the significance of the subject under discussion. The LHC, or Large Hadron Collider, built by CERN, represents a remarkable accomplishment in science. Spanning 17 miles, this extensive superconducting network is not only the largest but also the most powerful particle accelerator ever constructed. It stands as an impressive illustration of human ingenuity and intellectual advancement. The LHC is so powerful that it has the ability to recreate conditions similar to those present at the universe's creation. However, as we investigate the vast nature of the universe, we must ask, could this machine, whose goal is to unravel existence's unsolved mysteries, also expose us to unexpected dangers? CERN, established in 1954, is one of the most well-known scientific research organizations in the world. With 23 member countries and a vast community of researchers, it serves as a hub for innovation and collaboration. While its flagship project is the LHC, it is only one element in a vast network of particle accelerators and experiments. Consider the LHC as a racetrack, not for horses or automobiles, but for subatomic particles, racing against one another with extreme speed and precision. Protons in the LHC are accelerated to nearly the speed of light, replicating the energy levels that existed when the Big Bang occurred. The resulting collisions produce temperatures significantly higher than those found in the Sun's core. Guided by powerful magnets, the protons are kept on their trajectory, while advanced cooling techniques maintain the magnets at temperatures far colder than outer space. These collisions occur at 4 distinct points in the accelerator, where specialized detectors, ATLAS, CMS, ALICE, and LHCb, collect data. Each detector has a unique function, offering diverse perspectives on the results. Together, they act as massive cameras, capturing snapshots of the aftermath, allowing scientists to analyze the data for elusive elements like the Higgs boson, also known as the God particle. By studying the subatomic world, scientists hope to deepen our understanding of the cosmos. Yet, each new discovery tends to raise even more questions. The LHC is not just a tool, it symbolizes humanity's insatiable curiosity and relentless pursuit of knowledge. However, as we push the boundaries of the unknown, we must also confront the existential and ethical dilemmas that accompany this pursuit. Probing into the unknown carries potential risks. Knowledge opens doors to forces beyond our control. At CERN, where the limits of human comprehension are constantly tested, an alarming realization has come to light, one that has even unsettled experienced scientists. Brian Cox, a former CERN researcher and renowned figure in particle physics, recently made a troubling statement that has sparked global concern. He asserts that the LHC's objective is to recreate a miniature version of the Big Bang, the event that gave birth to our universe. He further described the LHC's enormous potential for groundbreaking discoveries, including unraveling the mystery of dark matter, a significant yet elusive component of the universe. The possibility of harnessing the fundamental forces of the universe is undoubtedly exciting, but it also carries inherent dangers. The idea of a mini Big Bang is not just theoretical, it is an actual occurrence within the LHC, where extreme heat, pressure, and energy are generated, mimicking conditions from the dawn of time. Observing the birth of the universe in a controlled environment is an awe-inspiring feat, but with great power comes great responsibility. A single miscalculation could have unforeseen consequences. This concern is not new. In 1978, Russian physicist Anatoly Bugorsky experienced a harrowing incident while working with the U-70 synchrotron at Russia's Institute for High-Energy Physics. A malfunction caused a high-energy proton beam to strike his head, entering through his nose and exiting the back of his skull at unimaginable speeds. The beam's intensity was so extreme that he witnessed a flash of light brighter than 1,000 suns. Miraculously, he remained conscious and even walked to receive medical treatment. Despite losing hearing in one ear and suffering partial facial paralysis, his cognitive abilities remained intact, and he continued his scientific work. Bugorsky's experience serves as a stark reminder of the immense power and potential dangers of particle accelerators. The risks associated with a collider as powerful as the LHC cannot be underestimated. Some scientists fear that the LHC might produce minuscule black holes, regions in space where gravity is so intense that nothing, not even light, can escape. Black holes are mysterious, destructive forces lurking at the edges of the cosmos. The notion that the LHC could create a small black hole is both fascinating and terrifying. Could such a black hole expand uncontrollably, consuming the Earth from the inside out? CERN researchers have assured the public that any black hole created would be highly unstable and would evaporate almost instantly. Nonetheless, the mere possibility has sparked intense debate and concern. To understand how the LHC could theoretically generate a black hole, we must first examine how particle accelerators function. When protons collide at near-light speeds, the resulting energy is so immense that it could potentially warp the very fabric of spacetime. Imagine a trampoline. When a heavy object is placed on it, the fabric stretches. If the object is dense enough, it could create a severe depression, pulling everything around it inward. This analogy helps illustrate how extreme energy conditions at the quantum level might affect spacetime. A controversial theory suggests the existence of hidden dimensions beyond the familiar 3 dimensions of space and 1 of time. If these additional dimensions exist, the LHC might have the capability to access them, potentially leading to the creation of a microscopic black hole. This possibility has captured the attention of prominent physicists, including Stephen Hawking. Hawking warned that the Higgs boson could become unstable at extremely high energy levels, possibly resulting in catastrophic events such as vacuum decay. Astrophysicist Sir Martin Rees also expressed concerns about the LHC in his book on the future of humanity, discussing the remote but potentially disastrous consequences of vacuum instability. While he acknowledged the likelihood of such an event is exceedingly small, he emphasized that even a slight possibility should be taken seriously, given the high stakes. CERN researchers have conducted extensive analyses and simulations to ensure the safety of LHC experiments. Brian Cox himself acknowledges these concerns but stresses that rigorous safety measures are in place. Strict protocols and thorough checks ensure that the collider operates within safe limits. Additionally, the energies involved in LHC experiments are lower than those naturally occurring in cosmic ray collisions on Earth. Even if a microscopic black hole were to form, it would be so minuscule and unstable that it would immediately evaporate, releasing a tiny burst of energy, as predicted by Hawking radiation theory. Some speculate that LHC experiments might open a gateway to another dimension or parallel universe. While mainstream scientists generally dismiss this idea, it has fueled public imagination and conspiracy theories. The concept of parallel dimensions is not new, especially in string theory. To captivate the general public, despite the fact that conventional scientists remain skeptical of the LHC's potential to open a gateway to hell or another universe, the concept of the LHC as a cosmic key that unlocks new possibilities continues to pique the imagination. Should we be concerned about the numerous risks of the LHC? It is easy to fall prey to sensational headlines and worries about a cosmic catastrophe. However, the truth is that scientists at CERN are very aware of these possibilities. They have taken every preventative measure to guarantee safety. Experiments and monitoring are conducted indefinitely, examining their work with great care. The research's potential benefits, such as unlocking the secrets of dark matter, locating brand new atoms, and enhancing our knowledge of the universe, are truly amazing. While these accomplishments mark a significant advance in human knowledge, they do not come without danger. Like all significant scientific breakthroughs, the experiments carried out by the LHC raise important questions. Could they lead to the production of exotic high-energy particles or conditions that impact us in ways we cannot anticipate? Careful consideration of the broader implications of scientific advancements is necessary. The Large Hadron Collider stands as evidence of human creativity and curiosity. It has already sparked revolutionary advancements in particle physics, providing answers to some of the universe's greatest mysteries. But as we venture further into these uncharted regions, we must remain vigilant and aware of the dangers involved in the search for knowledge, one of the most ambitious projects in human history. However, this pursuit does not come without its difficulties. The LHC symbolizes the cutting edge of scientific research, where theory meets experimentation, testing the very fundamentals of our knowledge of the universe. There is always risk involved in discovery, and the LHC is no exception. It pushes the limits of physics, attempting to reconcile the primary forces of nature, answering questions about the origins of mass and the nature of dark matter. As we continue to investigate these frontiers, we must also consider the moral and existential questions that arise from manipulating the forces of the universe. The possibility of unintended consequences, whether for our planet or for the fabric of spacetime itself, remains a challenge that requires careful thought. Despite this, the pursuit of knowledge remains one of humanity's greatest endeavors. The LHC's experiments, although risky, offer us a glimpse into the vast, undiscovered regions of science awaiting exploration. Standing on the edge of discovery, our journey into the heart of the universe's mysteries requires both ambition and caution. The LHC not only represents the pinnacle of human technological progress but also serves as a powerful instrument capable of reshaping our perception of everything, from the tiniest particles to the largest cosmic phenomena. Each breakthrough leads to new questions, taking us down unexplored paths in the journey of scientific discovery. The promise of revelations that could alter our understanding of our place in the universe is both thrilling and humbling. One of the most important aspects of the LHC's experiments is their intersection between theoretical and practical physics. For decades, physicists have struggled to unify the fundamental forces shaping the universe: gravity, the weak nuclear force, electromagnetism, and the strong nuclear force. The hope has always been to bring these forces into a single, cohesive theory. The LHC has been instrumental in providing insights and experimental evidence that bring us closer to this elusive goal. Beyond expanding our understanding of particle physics, the LHC holds the key to uncovering fundamental truths about existence itself. However, such groundbreaking experiments also raise ethical concerns. The pursuit of knowledge has always come with risks, and when those risks involve altering the fabric of space and time, the stakes grow even higher. Could an experiment at the LHC accidentally trigger a phenomenon we don't yet understand, leading to unavoidable consequences? This question will continue to challenge scientists, philosophers, and ethicists as we explore these uncharted territories. Despite these concerns, some argue that the relatively low risks are justified by the potential rewards. The LHC's discoveries have already revolutionized science, identifying the Higgs boson and advancing our understanding of dark matter. These breakthroughs have far-reaching implications, not only for physics but for many other fields that depend on this fundamental knowledge. As we continue pushing the boundaries of what is possible, the LHC serves as a reminder that science is never without uncertainty. Every experiment carries risk, and the LHC, despite its immense power, is no exception. Its monumental discoveries symbolize humanity's relentless quest for knowledge, driven by a desire to understand the universe, explore the depths of space and time, and reveal the forces that govern everything, from the smallest particles to the largest cosmic structures. This journey may come with risks, but it also represents humanity's greatest achievements in particle physics. The LHC challenges the fundamental laws of nature, attempting to solve mysteries that have persisted for millennia. Whether it will eventually unlock new dimensions, parallel universes, or cause unforeseen phenomena remains unknown. What is certain, however, is that it is one of the most powerful scientific instruments ever created, capable of uncovering secrets about the universe that were once thought to be beyond our grasp. There is no end to discovery. As we venture further into the unknown, science reminds us that exploration requires both bravery and responsibility. The experiments at CERN must be continuously monitored, ensuring that we carefully weigh both the potential risks and the incredible opportunities for deeper understanding. The LHC, standing at the forefront of modern science, is not just a tool of research, it is a reflection of our eternal search for meaning in a vast and mysterious universe.